1. Introduction. ASTRAX built a commercial spacecraft education and training simulator for Worldview Enterprises Voyager in 2017, which can be reconfigured into a simulator for Virgin Galactic's Unity in 2021. We also created a simple simulator with a stand screen made by printing images of the spacecraft's interior, and a virtual simulator created using Minecraft. We are also working on a simulator and virtual simulator for SpaceX's Crew Dragon. In the future, we also plan to build simulators for Blue Origin's New Shepard and Space Perspective's Neptune, as well as facilities that simulate space bases such as the Space Hotel, the Moon City, and Mars City. This paper will introduce the purpose and current status of those simulators, plans for future upgrades, and plans for new simulators to be added. 2. Location of the Spacecraft Education and Training Simulator. The ASTRAX Spacecraft Education and Training Simulator is located at the ASTRAX Private Space Business Development Education and Training Center in Sakaimachi, Ibaraki Prefecture, in Japan. Currently, 2 spacecraft education and training simulators are installed to simulate a cylindrical spacecraft and a capsule-type spacecraft. By reconfiguring the interiors, 3 different types of spacecrafts can be simulated. In the future, we also plan to set up simulators for other spacecrafts, space stations, space hotels. 3. Worldview Enterprises Voyager. Inside the Voyager Spacecraft Education and Training Simulator. The main body of this spacecraft education and training simulator is a 1970 Airstream, 9 meters long, camper. The entire interior of the camping car is removed and replaced with the interior of the spacecraft Voyager. Voyager has 4 large windows and a total of 8 seats, 6 passenger seats, 1 pilot seat, and 1 foldable attendant seat. The design of each seat in the simulator is different from that of a real spacecraft. We adopted a massage chair with a similar design based on images released by spacecraft developers at the time. Each seat is equipped with a tablet terminal for monitoring the situation, and the cockpit section has 3 touch panel monitors based on the images and other information released by the spacecraft developers. That part is not related to the seats, so it is just an image. The 4 windows are configured differently for the front and rear, and for the left and right sides. The left and right windows were designed using acrylic sheets and cutting sheets, and the scenery outside the windows was simulated using printed images, as the width of the Airstream did not allow for any special features to be incorporated. The left window facing the front is an image of Earth as seen from the stratosphere, and the right window is an image of the Tucson Spaceport Terminal, as if it were before takeoff. For the front and rear windows, we decided to create a section of the outside of the window between the window and the actual wall of the vehicle, since there was enough room in the vehicle length. A screen was erected in the area between the window and the wall of the Airstream itself, and a short throw projector was installed so that we could show the evolution of the scenery outside the spacecraft from launch, during the stratospheric flight, and during the return trip. The spacecraft is equipped with a counter bar, wine cellar and refrigerator, just like the real aircraft, to serve alcohol and snacks for customers to eat and drink during the flight. We also installed a private toilet room. This is similar to the toilets in airplanes and trains, with a toilet bowl and simple hand washing. However, the simulator is a mock-up and cannot be used as an actual toilet and water supply. The interior walls are also coated with a photocatalyst that deodorizes. The overall lighting in the ship is provided with tape lighting that has adjustable brightness and color to be changed in various ways according to the mode of spaceflight. In addition, there are electronic bulletin boards at the front and rear of the spacecraft, just as in the actual spacecraft, which can display speed, altitude, and announcements. The display contents can be changed by connecting a PC and replacing the data. Each seat has a sound system that can be connected via Bluetooth, making it possible to play background music or broadcasting during the flight, presumably different from the actual spacecraft. The interior walls are also upholstered with artificial leather containing cushioning material, just like the real thing, maintaining a sense of luxury. In addition, the display terminals in each passenger seat and the touch panel in the cockpit have been integrated with Apple iPad terminals so that they can be linked to the ASTRAX Space Mission Support Control Center for smooth mission execution. Purpose of using the simulator. ASTRAX used this spacecraft training simulator for a variety of purposes, including training for commercial astronauts, called mission commanders, training for spaceflight attendants, image training and rehearsals for boarding customers, education for space travelers and businesses that support space travelers, and education for children. The spacecraft was used for a variety of purposes, including filming promotional videos, educational videos, and events. However, Worldview Enterprises has announced that it will stop developing the Voyager spacecraft around 2019 to focus on unmanned stratospheric missions, and that its CEO and vice presidents have started a separate company, Space Perspective, to develop manned spacecraft. Therefore, this spacecraft simulator was converted into a simulator for Virgin Galactic's Unity, which is shown in Section 4, so that it can be reconfigured for use. 4. Virgin Galactic Unity Physical Simulator. The Virgin Galactic Spacecraft Simulator is a modified, reconfigured, version of the Airstream used in the Voyager simulator shown in Section 3. This is because the development of the Worldview Enterprises spacecraft was stopped, and at the same time the manned test flights of the Virgin Galactic spacecraft were going well. The original interior walls were removed, stored for later reuse, and the simple simulator screen described in later this presentation was attached to them. As a result, a very realistic simulator of the Unity cabin was created. This simulator has 6 seats just like the actual spacecraft. The seats installed for Voyager were used. Therefore, the design of the seats is different from the actual seats. You can check the seating position of the passengers and check the movement and flow of each person during the mission in space. The cockpit section and the 2 pilot seats are basically flat and substituted with screen images, as it is not relevant to customers. In the real Unity, each seat has a monitor on the back to display information for the back seat passengers, but this simulator does not have that yet. The 17 windows are currently all screen images. The windows are supposed to be illuminated to match the outside of the window frames, but that has not been simulated yet either. The lighting in this simulator is an appropriation from Voyager, with line lighting on the ceiling and floor, not the same as the real thing, but for rehearsal and training purposes, this is not a problem. There are cameras on the edge of each window to capture video, but this is also not simulated in the current simulator. The hatch part is also substituted with a screen image and cannot be accessed. We plan to gradually increase the fidelity of the above parts that differ from the actual spacecraft as needed when we can secure the budget and upgrade it in the future. The Airstream is equipped with standard air conditioning, which makes the simulation cool in summer and warm in winter. The computers used in the simulator and the portable terminals installed in each seat are all Apple MacBooks and iOS devices, such as iPhone or iPad. This makes it easy to link with the Space Mission Support Control Center at the ASTRAX Space Center and the ASTRAX Academy Education System. In addition to the spacecraft simulator, we also built a replica of the flight suit. This makes it possible to have an experience close to the reality of the actual spaceflight. Simple Screen Simulator. This is a screen representation of the interior of a spacecraft. The front cockpit area, the left window area, there are separate screens for each of the 3 rows, the right window area, and the rear wall, which is a hemispherical mirror that matches the rocket's fuel tank, are represented with screens. In total, 8 screens are used, with each of which can be attached to a frame, with a stand that allows them to stand up. By arranging them in a square and placing 6 chairs inside, 8 if the cockpit is also simulated, it is possible to simulate the interior of a spacecraft with a certain degree of realism. If the screen is attached to the wall of an exhibition booth at a trade show, a simple experience corner can be created. Such a simple simulator can also function well when rehearsing the seating order and arrangements during a spaceflight. Above all, the production cost can be kept to a few $100,000, which is much lower than the cost of making a real simulator. Virtual Spacecraft Education and Training Simulator. This is a virtual Unity simulator using the children's game, Minecraft. A physical simulator is very difficult to reconfigure once it is built. On the other hand, the actual needs of customers are very different. The details of their needs and missions vary widely during the preparation stage. Therefore, it is necessary to flexibly reconfigure the interior of the spacecraft and test the layout to meet those needs. Naturally, using an actual simulator would be more realistic, but it would be costly, time-consuming, labor-intensive, and even more difficult when there are reworkings with trial and error involved. Therefore, we decided to use the virtual spacecraft training simulator in Minecraft to create a simple model first, and then verify it by reassembling it. 5. SpaceX Crew Dragon Simulator. ASTRAX is currently building two types of simulators for SpaceX's Crew Dragon spacecraft. The first simulator is based on a dome-shaped assembly house called Easy Dome. It is about 3 meters in diameter and 2.6 meters high and can be easily assembled. The interior of the SpaceX Crew Dragon will be simulated by placing 4, or 7, bucket seats in the Easy Dome, 3 touch panel monitors in the ceiling, and lighting and other equipment in the ceiling and floor sections. The touch screen monitors are designed to be using Apple devices so that they can be linked with other simulators shown in sections 3 and 4, as well as with the space education system of the ASTRAX Space Mission Support Control Center and ASTRAX Academy. Portable air conditioners will be installed for summer and winter as needed. The project is currently in production and is expected to be completed by the end of October this year. Please refer to the paper that will be prepared and updated in the future for more details. The second is a virtual spacecraft education and training simulator using Minecraft, which was introduced in Section 3. 6. Simulators and simulated facilities to be created in the future. In addition to the simulators of each company shown in Sections 3 to 5, ASTRAX plans to build the following simulators and simulated facilities for spacecraft and space bases in the future. 6.1. Blue Origin's New Shepard. We will also be using the Easy Dome for Blue Origin's New Shepard simulator, which we are using to build the Crew Dragon simulator in Section 5. There will be 6 seats in the dome and a small status monitor in the window of each seat. In the center of the dome, we will build a bulge for the escape motor. Lights and cameras will be installed similar to the real spacecraft. 6.2. Space Perspectives Neptune. Space Perspectives spacecraft, Neptune, is a relatively large circular body that can accommodate 9 passengers. It is still undecided what to make the main part of the simulator out of. The spacecraft has 8 seats, 1 pilot seat, a counterbar in the middle, and a toilet underneath. It will have large windows in all directions for spectacular views. 6.3. SpaceX's Starship. There are at least 2 types of Starship simulators that need to be built. Because they are so huge, they cannot be portable and will need to be installed in a special facility. The first is Starship for long flights, such as to the Moon or Mars, which will take several days to several months. 100 passengers will need cabins for each of them to sleep in. It will need toilets, shower rooms, a kitchen, a training gym, etc. It is similar to a cruise ship. In some cases, it may be possible to purchase a used ship and remodel it. The second is a simulator of the Starship for flights between 2 points on Earth. It will have a seating capacity of up to 1,000 people. It would be similar to the economy class of an airplane, with lots of seats in a row. However, we need to fundamentally examine whether we actually need to build such a spacecraft simulator. This is because it is unlikely that there would be customers who would use such a huge spacecraft for a short mission of about 30 minutes. Even if we were to build a simulator, we think it would be better to prepare one that simulates only some of the functions for training attendants rather than for customers. We are also considering remodeling a hotel on the ground or a used cruise ship to serve as a simulator. 6.4. Lunar City, Lunar Base, Simulation Facility. ASTRAX is preparing to build not only a spacecraft, but also a simulator for ASTRAX Lunar City, Lunar Base. ASTRAX has a business community and a residence club called ASTRAX Lunar City, and as of August 2021, about 350 companies have joined. We are also working on virtual mapping and other activities to make effective use of the lunar land owned by those members. In addition, we are planning to build a Lunar City simulator for education and training, where people can stay overnight. The current concept is to combine dozens of Easy Domes to create lodging area, communal living area with cafeteria, bath and toilet area, spacesuit changing area, and airlock area. For the communal living area, we are planning to use large gel tents instead of Easy Domes. We are also planning to use large gel tents for the communal living area, so that people can wear spacesuits when they go outside and can live self-sufficiently inside the facility. In Japan, where there are many disasters such as earthquakes and floods, these facilities can be used as a training ground for evacuation in times of disaster, so we are also considering ways to use them other than space travel. 6.5. Mars Base Simulation Facility. A simulated Mars base will be built as well as a lunar city. If it is on the Moon, it is easy to schedule a return to Earth, so the duration of their stay can be for a few days to a few weeks. However, it will take a lot of preparation to be able to stay on Mars for a long time, so we will use existing facilities such as High Seas and Biosphere 2 in Hawaii for the long stay. What we will prepare in ASTRAX is only for the purpose of experience, education, and research and development. We believe that the duration of the possible stay should be equivalent to that of a lunar city. In some cases, the Lunar City Education and Training Simulator described in Section 6.4 may be used as is. 6.6. Space hotels and other simulated facilities. We would like to set up not only a spacecraft, but also a space hotel, which is a long-term stay facility in orbit, and a simulated facility for the International Space Station. The current plan is to use some of the guest rooms of ordinary hotels and capsule hotels operating on the ground to simulate the guest rooms of a space hotel. The purpose of this project is not to simulate a self-sufficient life, but to develop the services and improve the technology required for a stay in a space hotel. We also plan to provide a simulated space travel experience for people who will not actually go on a space trip. Conclusion. In this way, ASTRAX is developing, including planning, spacecraft, space bases, and space hotel simulators for each company, to enhance spaceflight and space travel by general customers and provide better services. We develop various systems, equipment, train personnel, conduct education and training, and provide actual mission support. We will continue to evolve various services, facilities and systems, human resources and platforms associated with space travel, such as the ASTRAX Spacecraft Education and Training Simulator, Space Mission Support Control Center, and Mission Commander. In addition to physical education, training simulators and equipment, we will also further develop simple simulators and Minecraft simulators for simple education and awareness. At the same time, we will add functions to link with high-quality VR training systems and e-learning systems. As the market for private space services expands, it will be necessary to conduct rehearsals in various ways to ensure the success of each mission. At ASTRAX, we will not spend a lot of money like a national project. Instead, we will focus on how to reduce costs by eliminating waste and how to conduct training and rehearsals in a simple way with a minimum system to meet the objectives and ensure the success of actual space missions. We will continue to challenge ourselves to succeed in actual space missions.